So all of our independent variables are statistically significant at the 1% level. So we think with each of these variables, with your income, with how old your oldest vehicle is, and whether or not you've recently had an addition to your family, that all three of these things will change the likelihood that you will purchase a new car. So we have that feeling. Any questions about this idea? Everyone feel comfortable with the idea of statistical significance here? As I said, it's not really any different than what we did with multiple regression in terms of the basic concept. The concept of statistical significance is just, does changing the independent variable have an impact upon the dependent variable? Now, the key difference, though, is the interpretation part. The key difference now is the interpretation part. Can I remove this page? The interpretation's a little bit different for this. So for example, income in this case. Its coefficient is 0.078. Now, before we would interpret that, you'd say, well, for every extra dollar, your likelihood would go up by 0.078. But if you remember, the function is really, your odds are e raised to this power. Okay? So it's a little bit different in terms of, we really are not going to interpret that B1 directly. What we need to find is we need to find e raised to the B1 power. That what we want to do is we want to find out what is e raised to the B1 power, and that is the relationship between the odds and income level. So what we need to do is find that. Now, thankfully, SPS directly provides this for us. What we have here is we have income. We have its coefficient, 0.078. If we go all the way over here, we see the exponential of B, 1.081. That is what we are looking for in this case. Okay? What we're interested in is not actually B1. What we're interested in is the exponential of B1. And the exponential of B1 in this case is 1.081. So what we're going to do is when we want to interpret the coefficient, we actually are not going to look here, but we wish to look here at the exponential column. So if you wish to interpret, don't look here, but instead look right here. So we're going to have to kind of, we have the coefficients which help us form the equation, but the interpretation part is by looking at this exponential. So, what does this mean? What does this mean? Well, what this says is this says This is for every $1,000 increase in a household's income. The reason why I say 1,000 here is that when I raise income by 1, I'm really raising it by $1,000. Because I've measured income in thousands of dollars. When I raise income by 1, it's not raising it by $1. It's raising it by, in this case, $1,000. So for every $1,000 increase in a household's income, what this is for every $1,000 increase in a household's income, the odds of purchasing a new car increase by 1.081 times. So what you could say is that maybe before the odds of purchasing a new car were 20%. Okay? What this is saying is that if my odds before were 20%, if all of a sudden my income increases by $1,000, the odds of me purchasing a new car would be, instead of 20%, they'd be 20 times by 1.081%. So what I would do is I would take my odds from before and then multiply them by 1.081. So if my odds before were 20%, then they would go up to about, not quite 22%, be like 21.6%, I think, approximately. So they go up a little bit. So they would go up a little bit. But what this is saying is this is talking about how do the odds change. So in this case, what it's saying is that the odds of me purchasing a new car, my income goes up by $1,000, is I need to multiply those odds by 1.081. Or if you want to think about it, they go up by about 8%. Any questions about this? Some ways you have to almost, I want to say, work through the math, but in a way what you're going to do is you could look at, as I said, if a family you think has a 20%, the odds are 20% for them purchasing a new car. Then you just multiply it by this 1.081. Questions? Remember, you're not only asking questions for your class, you're asking questions for the 330 class. Well, we can do the other two variables. So if we do, in this case, vehicle, okay? So if we do oldest vehicle, it has a coefficient, in this case, of 0.818, or if I take that coefficient and then raise e by that power. So if I take the exponential, raise it by the power of b2, what I would get in that case is 2.266.